Ladies and gentlemen, and welcome to our 4.3 section on solving radical equations and n-through equations. We're really going to focus on the radical equations this segment, and towards the end and in class we can start talking about different n-through equations. Here's a little warm-up for you guys to try if you're up for a little bit of a challenge. Remember we talked about last time conjugates and how you are not allowed to keep a radical in the denominator. So I'm going to give you guys a minute to pause your video, try the warm-up, and then join me when you're ready. Okay, there's our final answer for the warm-up. If you had any questions on it, you'd like me to go over it, make sure you catch me in class. All right, let's get started. First, I want to go over what a radical equation is and what a radical equation is not. When you're working with a radical equation, you want to make sure that the radical has the variable inside. Okay, if you'll notice the second example underneath here, this is not a radical equation. Okay, the square root has just a number in it, so that's not considered a radical equation. When you're solving radical equations, there's a couple different steps that you're going to take. First thing you want to do is isolate the radical. And then if you think of your inverse operations, squaring something and taking the square root of something are inverse operations, and that's what we're going to end up using in order to solve for x. One of the big things that we've been focused on our last unit and this unit as well is checking for extraneous solutions. So if you happen to come up with your answers, make sure you go back, either use your calculator or by hand, and check for extraneous solutions. So we're going to start with this equation here, 5 times radical x plus 2 equals 12. So the first thing that we're going to want to do is we're going to isolate our radical. So I'm going to start by subtracting 2. So I now have 5 radical x equals 10. And I'm going to divide by 5 on both sides in order to isolate my radical. So I have the square root of x is equal to 2. Now, in order to undo that square root, or do the inverse operation, I need to square both sides of my equation. So the square root of x squared is just going to leave me with x. And then 2 squared gives me 4. So there's my solution. And I want to make sure that I check my solution to make sure that I didn't end up with an extraneous one. And you can either do this by doing it by hand, or you can use your store option in your calculator. Okay, if I do it by hand, I'm just replacing x with 4, because that's the solution that I found. Alright, now the square root of 4 is a perfect square. That's 2. So this is really 5 times 2. So that's going to be 10 plus 2 equals 12. And I do know that 10 plus 2 is 12. And so our answer checks. So we are good to go. Alright, let's take a look at the next one. First step we're going to do, isolate that radical. So we're going to start off by subtracting 2 from both sides. So we have the square root of 2x plus 1 is going to equal 3. And in order for us to get rid of that square root, we've got to do the inverse operation of just squaring. Now, if I square the square root of 2x plus 1, I just end up with whatever expression is inside my radical there. So this is just going to be 2x plus 1. And 3 squared is 9. Here you have a nice linear equation that you can solve now. So we'll subtract 1. We got 2x equals 8. And our last step is to divide by 2. And now we have x is equal to 4. And if you go ahead and check that into your calculator, if you forgot how to check into your calculator, let's try that for a minute. So if you take your calculator, make sure you're on a calculator page, and I'm going to store x as 4. Okay, so, oops. Sorry about that, I had a little technical difficulties with my calculator. Let's try this again. Let's store x as 4. Okay, so x is now 4. Now I'm going to put in my equation, which was the square root of 2x plus 1 and that was plus 2 equals 5. Now, if 4 is definitely a solution and it's not extraneous, this should say true. And it does. So I've checked my solution. I know that it works. All right, let's go back to our notes. In example 3, if you'll notice, we have a square root on both sides of our equation. So in both of them, if I divide by 2, I'm not really isolating either one of my radicals. So what I'm going to do is I'm going to leave the 2 there. I'm just going to start off by squaring each side. Now, if I square the right-hand side of my equation, that one's a little easier. That's just 3x plus 4. If I square the left-hand side, though, that is 2 times the square root of x minus 7 times 2 radical x minus 7. So what I want you to notice is that I had to multiply 2 times 2 here. So this actually technically gives me 4 times the quantity x minus 7. Because the square root of x minus 7 times the square root of x minus 7 is simply x minus 7. Alright, what do you think my next step's going to be? You guessed it, distribute. Nice job. So we're going to do 4x minus 28 equals 3x plus 4. Alright, we're going to go ahead and solve it from here. I'm going to do 2 steps in once here. I'm going to subtract 3x and add my 28. So those cancel, so we end up with x being equal to 32. Okay, and if you go ahead and check that in your calculator, that will check. It is not extraneous. All right, nice job. You guys are doing a good job so far. Let's go on to the next one. Let's try one more together, and then I'll let you do one on your own. I'm going to isolate my radical for this one, so I'm going to subtract 1. So I have x minus 1 is equal to the square root of x plus 11. So my radical is isolated. I can square both sides. Notice on the left-hand side of my equation, I am squaring the entire binomial. So when I multiply this out, I have to multiply x minus 1 times x minus 1. Here's where those of you that like your box method to multiply binomials together, you're going to want to use that. Right? And our right-hand side just ends up being x plus 11. All right, so now I'm going to multiply out my left-hand side here, and in the end, you should end up with x squared minus 2x plus 1. So no matter what method you use, double distribute your box, whichever one you like best, you still should have come out with x squared minus 2x plus 1. Now, this is a quadratic equation, and in order for us to solve a quadratic, we've got to set it equal to 0. So these two terms over here on my right-hand side, they're going to come over to my left-hand side, because I want this equal to 0. So I have x squared minus 3x minus 10. All right, how do you solve a quadratic? You're right, there's a lot of different ways that you can solve a quadratic, and we're going to look at factoring this one. All right, so we're going to start off with x's here. All right, so I need factors of negative 10 that add up to negative 3. Nice, negative 5 and positive 2. All right, so my two factors are x minus 5 and x plus 2. So if I solve both of those, I end up with solutions of 5 and I end up with another solution of negative 2. All right, now I'm going to tell you one of those is extraneous. So I want you to pause your video, test both of those, and come back and tell me which one is extraneous. All right, which one did you find to be extraneous? Negative 2, good job. All right, so 5 is our only solution here for this one. All right, so now I think we've reached a point where you guys can try one on your own. So go ahead and pause your video, try number 5, and after you've solved it and checked your solutions, you can come back and join me. All right, so you should have gotten solutions of 4 of 2, and when you checked them, they both end up working. So we end up having 2 solutions for this one. All right, how'd you do? I'm sure you did great. All right, let's move on to the next one. Okay, number 6. I want you to try this one on your own too. Okay, if you had a little trouble with that last one, make sure you start off by squaring both sides. And when you square the right-hand side, remember you have to multiply it by itself. All right, so I gave you a little head start on that one. Go ahead and finish out that question, check your solutions, and join me when you're ready. This one was just a little bit trickier than the last one in the sense that when you got done setting your equation equal to 0, if you notice you just had, and I'm looking at this line down here, if you notice you just had x squared plus x. So what I did was I ended up taking out a GCF. So in this line here, there is a GCF of x. So after I took that out, I ended up with two factors. My factors were x and x plus 1. So those are the two expressions that I set equal to 0 in order to figure out what my solutions were. And if you didn't already, make sure you check them. They both do check, but make sure you get in the habit of checking your solutions. Number 7, notice there's two radical equations, or radical terms here in this equation. So this one's going to be a little bit trickier, and if you're up to the challenge, you can go ahead and join me for the example number 7 and for the challenge question after that. If you're feeling like you're pretty okay with the material, you can actually stop your video now and go ahead and fill out your form. But for those of you ready for the challenge, let's go. First thing I'm going to do is I'm going to subtract this radical x. And I'm going to end up with the square root of x plus 5 is equal to 5 minus radical x. And what I'm going to end up doing is I'm going to end up squaring both sides. So I square both sides here, so that gives me x plus 5 over here. But on the right-hand side, I actually have to write it out twice and multiply it. So this is going to be 5 minus radical x and 5 minus radical x. All right, so go ahead, pause the video, and multiply that out for me. Okay, after you got done multiplying, you should have 25 minus 10 radical x plus x. All right, now notice I'm down to one radical term now. I'm going to isolate that radical term. So I'm going to subtract x and 25 onto the left-hand side of my equation. And in doing so, you'll notice my x's cancel. So I now have negative 20 is equal to negative 10 radical x. Remember, they're being multiplied over here, so I can divide by negative 10. And I end up getting 2 is equal to the square root of x. So I'm going to actually have to square this one more time in order to solve this. So this becomes 4 equals x. And if you go ahead and check it, it'll all work out. So in that question, we had to actually square both sides twice throughout the question. All right, if you are really up for a challenge, go ahead and try this challenge question. You'll have to square both sides a couple times, maybe a few, throughout your solving in order to figure out what the solution is. And when you're ready for the solution, you can go ahead and join me. Okay, how'd you do? Did you end up with 3,844? If not, take a look at my steps that I did. Notice what I did along the way to solve. And if you have any questions, I'll see you in class. All right, that's the end of our video. Go ahead and fill out your Google form, and I'll see you in class.